Good afternoon, ladies and gentlemen. Today we're going to be talking about the SIMULIA 2019 product updates for Aventec. So a message from our president, Jay Shin. So we are Canada's leading provider in best-in-class 3D experience technology by Dassault Systems. We specialize in CATIA, SIMULIA, Delmia, Innovia, 3Diva, and Exley to help engineering and manufacturing companies to improve their competitiveness, productivity, and profitability, utilizing our expertise in Dassault Systems cross-industry solutions. Today's speaker will be Hicham Farid. Hicham holds the position of CAE FEA Specialist at Aventec. He has a PhD in fracture mechanics of brittle materials from the University of Quebec. His major interests are material modeling, brittle materials, plastics and composites, as well as fatigue and creep interaction. Before joining Aventec, Hicham spent 8 years working as R&D and engineer scientist at different organizations.
Well, thanks for the presentation, Lauren. I'm just going to carry on with the presentation of today about the SIMULIA updates of the different products for 2019 portfolio. I'm just going to start with a quick overview of the Abaqus 2019 updates in terms of the solver, and then carry on with the Abaqus CE updates, and then we're gonna see like a quick overview of the SIMULIA portfolio, including the other 3 products, Isight, Tosca, and Isight. And yeah, so let's start with the Abaqus 2019 updates. We can talk about tremendous amount of updates in terms of the iterative solver in order to provide high fidelity simulation by combining the DMP and SMP efficiency, efficient memory management, in order to provide also a faster and more reliable conversions for different complex problems. And we can see a significant jump from higher and higher to higher and higher number of degrees of freedom. We can talk about the 100 million degrees of freedom and e to the power of 15 flops, which allows different users to model larger and larger assemblies with within a faster amount of time. We always talk in the previous whenever we talk about any updates in the current release, we always compare or tend to compare with the previous releases, what happened in the previous release and how it compares to the newest one. So in the past, we talk a lot about the linear dynamics in Abaqus, starting with Abaqus 2017, 18, and now with Abaqus 2019. A large amount of capabilities have been added to Abaqus 2019, in order to provide a large amount of capabilities, including scalable solvers in terms of advanced mechanics and other provided features. We can talk about the Abaqus EVL, Isight usability for multi-body dynamics, powertrain simulation, the analysis of multiple load cases, the matrix output enhancements, as well as the Tosca optimization workflow enhancements, which we're going to talk a little bit more details when we see the Tosca 2019 product updates. We also updated the Nastran translator significantly, plus other improvements concerning the energy and the energy flow calculations directly in the direct SSD analysis. In the recent years, we've been talking about additive manufacturing as an enormous trend of the different cross industry, especially manufacturing industry. There's a bunch of other updates that have been related to this topic and added as part of the Abaqus 2019 capabilities. We can talk about the EigenString method when we add a specified user subroutine. Also, the orientation that could be predefined at the activation for solid elements, eigenstrings that are supposed to be calculated with full and partial activation, and new output variables, both field and history output, naming eigenstrings. The activation displacement output has been also added as new nodal output, named U activation displacement and UR activation. The output of the displacement rotation of the nodes from the time it becomes active. Also, we can talk about the improved convergence of heat transfer analysis, both now steady state and transient when linear elements and temperature dependent conductivity are used. Also, the implementation of the brick elements DC3D8. Some other enhancements to the event series, which concern only the sim file. The size of the file is no longer limited to 2 gigabytes or 53 million events. The user is able to define the event series with over 420 million events. Other enhancements related to the table collections can be defined as part of the material definition. Other parameters that can also have default values and be defined in a table with multiple rows. Additive manufacturing heat transfer energies for pure heat transfer analysis have been also enhanced as part of the Abaqus standard. We can talk about the other few types of energies that have been added as output can be requested from the history output, and other additive manufacturing enhancements related to the 2D and axisymmetrical elements that are now supported using star film load label, and also the type constraint that has been enhanced to use with the element activation. And concerning fracture mechanics, which is basically a hot topic, and a lot of clients are significantly asking about fracture mechanics enhancements within Abaqus. We can talk about the linear elastic fatigue, crack growth, and their mixed mode conditions that has significantly improved the performance, changed the contact condition within the loading cycle, and takes it into account a large geometric nonlinearities and also the mixed mode fatigue loadings. Contour integral improvements that help significantly reduce the pre-processing and also the post-processing within Abaqus standard. Extended finite element enhancements, especially for 3D non-planar crack, and also the symmetric cohesive elements. When we talk about the symmetric plane, that can be chosen at any plane which is perpendicular to one of the global coordinate axis and applied to both regular and pole pressure cohesive elements. And other enhancements are related to the user's subroutine in order to define the damage initiation, UDM, GIN, and I, which allows the user to define the varied crack initiation criteria for different enrichment zones. Concerning the element technology updates, we can talk about the poroelastic acoustic biot elements that have a use in terms of the steady-state dynamic direct linear perturbation in frequency domain only. We can talk about the 2 models that have been implemented into these elements by Johnson and by Atala. Shear panel elements have been also added and labeled as shear 4 with 4 nodes. These are special elements for modeling thin reinforced plates and shells, such as thin skins plates for aircraft wing and fuselage structures to model the response of a buckled plate, for example. However, these elements can support elastic material models only. The radius distribution and output for circular beams have been also added. The element solution dependent variable, which is a new concept, have been updated or enhanced within Abaqus standard, and it's used in user subroutines. Concerning the material model enhancements, we can talk about the low density foams in Abaqus as standard, the porous bulk modeling enhancements, as well as the new output variable SROG for rock mechanics effective stress. as well as the enhancement of super elastic material model, which is with the addition of the new environment variable to turn on modified formulation for super elastic material models. The material transverse shear modeling, which eliminate the need to define the star transverse shear stiffness with user material, and also the material failure and element deletion for concrete damage plasticity. The output enhancements for traction separation response for cohesive element have been added as a new output variable within Abaqus explicit. Other enhancements are related to the mean field multi-scale functionalities, especially when modeling composite materials. We can talk about the homogenization for viscoelastic composites, either at the time or the frequency domain, the damage and the failure at the microscale level, as well as the injection molding workflow, which can help now to define the fiber dispersion through distribution. And the fiber orientation can really be written from the SIM file, and which also include a mapping capability. In terms of contact, we see the introduction of the axisymmetric into the models for Abaqus explicit, which enables the use of the explicit general contact, as well as the analytical rigid surface in this Abaqus standard that enables the use of these capabilities in standard general contact with the use of either surface to surface, edge to edge, or edge to surface, as well as the vertex to surface. The thread interface approximation within Abaqus standard has been already enhanced with the fixed wrong sign to contact normal in some cases. With the addition of a new option in terms of small sliding contact normal locally associated with the top or bottom thread faces, which can be applied to either right or left-handed threads. Thermal and electrical contact capabilities are enable the user to use of general contact with pure heat transfer and coupled thermal electrical procedures. Also, we can note the addition of new contact output variables, such as CS slip equivalent or CS slip plastic strain and plastic equivalent strain as well. The improvement to the mechanical details in terms of the moments due to shell offsets versus the normal forces, or the shell thickness versus the tangential forces, as well as the cohesive in terms of the cohesive contact and the contact user subroutines, as well as the initial contact stresses. Let's switch gears and talk a little bit about the Abaqus CAE 2019 updates. There are a bunch of new capabilities that have been introduced to Abaqus 2019, including the flattened input file that supports for the model instance, as well as the part or the model instance in terms of the defining the translation, which now could be defined as a vector by coordinate system axis, by coordinate axis, datum axis, or any straight geometry edges. Then the user can specify the direction of the translation, a capability that helps a lot with placing the different instances as part of the assembly in the assembly module. The rotation as well can be specified now by directly picking an edge or an axis of rotation. The fluid inflator interactions and properties definition could be defined as part of the model flow characteristics of inflators for airbag systems, for example. And the fluid inflator properties could be defined as the part of the mass flow rate, temperature, inflation time data, and mixture of the gas entry and fluid cavity. For analysis of initially axisymmetric structural that undergoes a non-symmetric deformation, we see that the introduction of a new set of elements. Well, the elements have been already existing prior to the 2019, but just they were not supported as part of the Abaqus CAE. So we can talk about the first and second order continuum axisymmetric elements with asymmetrical deformation, C-axa and S-axa, where we can specify the first, the 1 to 4 free modes with extra nodes that are generated at the input file only, in case the user chooses to. In terms of optimization enhancements, we can see the incorporation of the greater capabilities of the Tosca within Abaqus interface, including the sensitivity-based shape optimization, where the user can choose sensitivity-based optimization for shape optimization tasks. Now we can note also the available options for optimization parameters like the design response, the objective functions, constraints, etc. That will vary accordingly depending on the chosen algorithm. There are also some Abaqus viewer enhancements as well that include the visualization of nodal tensor field outputs, as well as the invariant computation for complex frequency result, and also the rendering of the distributed beam radius, for example. Now we can talk a little bit about the other components of the SIMULIA portfolio, including Isight, FSAFE, and Tosca, plus Abaqus. These 4 products constitute what we call the power portfolio, known also as the SIMULIA extended packaging, which includes Isight, that is a parametric optimization software, which includes a bunch of other capabilities, such as the design of experiment, Monte Carlo analysis, Six Sigma analysis, and design exploration algorithms and techniques. The other software that we're going to be talking about today would be FSAFE, which is a fatigue and durability analysis software suite that works accordingly with Abaqus. And the last software would be Tosca, which is a non-parametric structural and fluid flow optimization, which include for the structural non-parametric optimization, including topology, shape, bed, and size optimization of different mechanical structures. So let's talk a little bit about the Tosca 2019 updates. Now, we can talk about the shell sheet sizing optimization, which is basically changing the thickness of a shell or the radius of a beam. Now, the three nonlinearities can be taken into consideration within Tosca, including the large displacements, contact, as well as nonlinear material models could be included. The same thing for shape optimization, which is basically the changing of the shape by moving the mesh in the normal direction to the surface, either inwards or outwards. As part of the sensitivity-based shape optimization, now Tosca can take into consideration the 3 nonlinearities, including the large displacements, contact, as well as a nonlinear material model, which allows for more flexibility and optimization formulation for non-parametric shape optimization. For example, minimizing the mass with stress constraints, for example. Other techniques that is also included for in Tosca is the bed optimization, which is basically changing the shell structure by moving the mesh in shell normal direction and creating what we call beds. These beds have as a role to maximize the frequency of the first mode frequency, for example, for a modal frequency analysis. Now, Tosca structure takes into consideration, again, like the 3 types of nonlinearities, including large displacements, contact, as well as non-linear material models, which helps a lot with making the sensitivity-based bid optimization faster and faster, and allows the users of different variabilities of solutions. We can see also, we can talk about the controller-based algorithm, which is the unique shape optimization solution for nonlinear analysis, which helps with faster design cycles. We can talk about less than 20 few design cycles, but allows little flexibility in terms of problem statement that could only take into consideration the volume and the mass, or the mass as constraint, as opposed to the sensitivity-based algorithm, which is very flexible in terms of problem statement, either in terms of objective functions or the constraints of the design. We can note also the improvement of the topology filter for the Tosca 2019 topology optimizer, especially in terms of handling the symmetry of different structure. We noted that there was a bug in Abaqus and Tosca 2018, pardon. The bug was in terms of filtering the different symmetrical structure, and mainly causes improvement for optimization with stress constraints. There's also some enhancements related to the functional regions that overhang with overhang constraints. The functional regions are not considered by the constraints and may remain as overhangs in the optimizer, in the optimized model. This is also supported within Abaqus. The functional regions are too big with overhang constraints. Some other enhancements, including enhanced manufacturing constraints for sensitivity-based shape optimization. The sensitivity-based shape optimization now supports the following manufacturing constraints: either the surface plane symmetry, the cyclical rotation, or with the symmetry constraint, as well as the cyclical plane symmetry, or the stamp and surface demolding for easier restriction of plane surfaces adjacent to the design area of the restrict on surface. This improvement will definitely help with defining smoother transition zones in different shape optimization models. The other products we're going to be talking today about the different updates as part of the SIMULIA portfolio is the FESafe. We can talk about the introduction of the introduction of the Weld Fatigue enhancements in terms of the other subset of the FESafe known as the Verity. We can talk about the improved weld info detection for solid models, as well as enhancement of the nodal forces options for structural stress calculations in the 2019 version, which helps eliminating the need for having perfectly structured meshes through the thickness below each weld line node. There's still a need for element faces in order to define along the assumed crack surface. We noted also the introduction of the theory of critical distances which only up to FESAFE 2017 only supported the normal stress algorithm. And then 2018, we added the support for algorithm-based barometering on shear stresses. The introduction also of some enhancements related to the vibration fatigue, especially in the time domain and also in the frequency domain. Other FESAFE 2019 enhancements are related to the optimization of the memory usage per material that has been reduced drastically. The increase of the hard-coded limit on the number of contours from 64 to 128, and the grouping, the groups of sets created by FESAFE are written automatically to ODB and can be visualized either on Abaqus Viewer or Abaqus CE. Other FESAFE 2019 enhancements are related to the new installer, as well as the prismatic Hall infinite life method that has been introduced already in Abaqus in FESAFE 2018. This algorithm is designed for complex multi-axial stress histories and allow tuning the different SN curves in bending tension, as well as in torsion. It's basically similar to the Dangvan theory and has improved accuracy under non-proportional load. The last software of the SIMULIA portfolio will be Isight 2019. We can talk about the SIMULIA execution engine enhancements with the introduction of the Tommy Microsoft SQL server-based SE that it's basically bundled with the SE, starting with the Microsoft SQL Server version 2017 that it's now supported. The new combination supports all the SE functionalities that are supported by the Tommy Oracle combination. We can note also the web dashboard in Tommy-based SE server, as well as the HTTPS support for the web top and web dashboard in Tommy-based SE. Now it's easier, it's being tested and also has been documented. The support of the copy paste of scripts in scripts editor. I know it sounds a little bit kind of like easier or smaller enhancement, but it's been like quite a pain to do so. The script editors automatically now detects the Isight parameters and other predefined variables in the passed scripts, and users may use external text editors and then copy paste the script into the editor UI. There is a new fetch and republish to local library command in the Fiber command right now, that it's available. The component, we can note also a bunch of internal components, enhancements all created the direct link to Abaqus now, noting CATIA V5 and then SolidWorks. And I guess with this we touch the end of our webinar today about the SIMULIA products, SIMULIA 2019 product updates. And back to you, Laura.
So I hope you guys got enough information about the updates that are happening for 2019. If you have any other questions or concerns, definitely reach out to us. You can call us at 905-305-1711 or contact Hicham directly. His email is right there on the screen, hfarid@aventec.com. Thank you again for jumping on, and we hope you guys have a great day.